HVAC, heating, air conditioning, ventilation in a passive versus a non-passive home. Let's start with ventilation, fresh air machines. Could be a HRV, could be an ERV, depends where the house is located. And great that building codes are demanding fresh air systems to be part of the house. But there's a big difference between a passive fresh air system and a non-passive fresh air system. Do you know that non-passive machines are required to be 60% efficient on average at 0 degrees Celsius? This is compared with a passive machine that's designed to be 90% efficient at minus 15 degrees Celsius. So there's a big deal here when it comes to comfort. The fresh air coming out of a non-passive fresh air machine could be anywhere from 5 degrees to 10 degrees inside the home. That's an uncomfortable position. The passive machines, because of the efficiency, because of their ability to extract up to 90% of the energy in the stale air that's leaving the home and transfer that energy to the cold air that's coming into the house at minus 15 degrees Celsius, the fresh air coming out of those vents into the living spaces is 17 degrees or higher. This is considered comfortable temperature. Your body stays comfortable. It's the reason why passive homes do not need a heat source in all secondary rooms. Heating and cooling, passive versus non-passive. Let's take your non-passive home, most often heated by a gas-fired or a propane-fired furnace or boiler. Big waste of money, because do you know just being connected to a separate utility, you're paying anywhere from $600 to $1,000 a year. So most people on gas would be paying anywhere from $1,500 to $2,500 in heating fuel. And if you're on propane, it's much worse than that, somewhere between $4,000 and $5,000 a year. This can be eliminated from the equation simply by building passive, building all electric. Now, building an electric house is very cheap regardless of where you are in the world with the use of a heat pump. You know, electricity is only being used to turn a pump and therefore can save anywhere from 200 to 500% energy factor of 2 to 5 depending on the temperature gradient. What's the end result? You know, that heat pump is only used a fraction of the year. We're talking a 3-month heating season in northern climates from approximately the middle of November to the middle of February. And that cost during that period, since it's only being used on an intermittent basis, approximately 200 hours all winter long is all you need for heating and cooling. $150 to $200 a year for all heating purposes, $50 a month approximately for cooling purposes. You do the math, a lot of money saved. Hot water heating in your passive home versus your non-passive. Now, most non-passive houses operate by gas. Obviously, hot water heating is going to be part of your $1,500 to $2,500 natural gas bill or $4,000 to $5,000 propane bill. All electric house, passive house. Hot water heating, though, just like the main heating system of the home, important to use a heat pump. So heat pump water heaters. And you know what it costs to heat all your hot water with a heat pump water heater? We're talking $100 to $200 a year. Very beneficial using a heat pump. The alternative to that would be a direct electric water heater, which some people choose to use as well. But since the heat pump water heaters have a 4-to-1 energy factor, standard water heating using simply a basic electric water tank is going to cost you anywhere from $400 to $800 a year, depending on how much hot water is heated. Reap the rewards for hot water heating. $100 to $200 a year, hot water heating cost. That's it. Exhaust in a passive house versus a non-passive home. Let's think about exhaust and all the exhaust vents in your non-passive house. There's exhaust vents from your clothes dryer. Every washroom has an exhaust vent. Your range hood in the kitchen most likely exhausts outside as well. These are big problems when it comes to the efficiency and the comfort of the house. You know, every time a house goes in exhaust, let's say the washroom and the clothes dryer was on, you're in the kitchen, all of that exhaust leaving the house puts the house into a negative pressure, which actually sucks a lot of air in. And the house is relatively leaky, meaning not airtight. Now you have an influx of cold air. You're going to have an influx of condensation that's going to lead to mold and mildew in wall cavities, roof cavities, building envelopes. It's why I've heard that a lot of non-passive houses built to more code standards are experiencing some type of mold or mildew growth within a few years after they are built. Okay, so exhaust should not be done on individual appliances, washrooms, kitchen. Everything should be done integrated into a whole house exhaust system, which essentially is what your passive house has. All of the exhaust is part of your fresh air system. It's part of your ERV system. So just like supply air is being supplied to all the bedrooms, all the living spaces, exhaust is happening from everywhere exhaust needs to happen. Washrooms, essentially every wet area of the home where humidity is going to accumulate, your laundry room, your washrooms, your kitchen spaces, possibly your utility spaces as well. But most importantly, to do with the clothes dryer. Heat pump dryers, heat pump is the theme in a passive house. So heat pump dryers should be used. Not only is it a huge energy saver, 1 to 2 kilowatt hours of energy for every time the heat pump clothes dryer is used, as opposed to 5 to 6 kilowatt hours of energy a non-heat pump dryer is used. But the most important thing is not having that penetration through the building envelope so that the indoor environment can stay comfortable, stay healthy, so that the ventilation for the entire home is balanced ventilation. Same amount of air comes in, same amount of air leaves the house, and that is a big part of keeping your passive home comfortable.